Hey everybody, and welcome to our second video in the topic of point slope form. In our first video, we derived the formula, where it came from. And now in this second video, we're actually going to tackle, well, what if you're given an equation in point slope form, like how do you get the graph? We certainly know how to graph slope intercept. We're experts at that. But what about point slope? So let's check it out. So if you look here at this first example, and this is if you have my note sheet. Certainly if you don't have my note sheet, you can certainly come along with us. You just draw it out on regular paper. But your first example is we're going to graph this equation. Now I hope you're realizing that this is point slope form. I'm actually going to write point slope form underneath it so you can see the connection. So let's remember point slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. So you can really see the connection here. The 3 is sliding in for the y sub 1, the 2/5 for the m, and the 1 for the x sub 1. So let's go ahead and identify some key components of this graph. First off, the slope. Well, the slopes is the m, and to me that's looking like 2 over 5. So I'm going to write 2 over 5 for my slope. And now my point. The point that's on the line. And if you remember back to when we derived it the other day on the video, the point that's on the line is x sub 1, y sub 1. So picking that out from this, I can see that my x sub 1 is 1. And my y sub 1 is 3. So 1, 3. Now, students may say or have said to me in the past, well, wait, isn't the x sub 1 like -1? Like, don't we take that sign and say it's like -1? The answer to that is no. And the reason is this minus is the built-in minus in the actual point slope formula. So because these are a match, the actual x value, x sub 1, is just the number behind that minus. Same for the y. This minus is built in to the formula, so the y sub 1 is just the number behind. So the point on the line, it's a little crazy because you kind of go right to left, which is a little awkward. 1, 3. Okay, so how do you graph it? Well, you have to go to the point first. You're going to plot the point 1, 3. So let's do that. 1, 3 would sit right here. And from there, you would plot the slope. So from here, we're going to go up to 1, 2 and right 5. 1, 2, 3, 4, 5. If you want to go opposite, down to left 5. 1, 2, 3, 4, 5. And that would be your line. Ta-da! You just graphed your first line from point slope form. And that's how easy it really is. Let's try the next one. Next example. Graph y minus 2. So I'm thinking of that as y minus y sub 1 equals m times x minus x sub 1. So again, it's flowing right into the form or right from the form. So let's identify slope. I'm seeing my slope as -3/4. And my point, again, working x to y, right to left, my x sub 1 looks like 3. And my y sub 1 looks to be 2. So I'm going to plot the point first, 3, 2. 1, 2, 3, 1, 2. And from that point, I'm going to come down 3 because of the negative. 1, 2, 3, and right 4. 1, 2, 3, 4. Or opposite, up 3, left 4. And that would be that line. Hopefully you're getting the hang of this. I hope so. Let's go to the next one. Again, if you don't have the note sheet, if I'm going too fast, you just pause me and write the example down. Okay, so here's our next one. Number 3. Okay, graph, point slope form, very similar to the others. So we have y minus y1 equals m times x minus x sub 1. So let's pick out the key ingredients. They don't call it point slope for nothing. Point slope, point slope, point slope. So the slope is 5. I hope you can see that. And the point. X sub 1 looks to be 2. And y sub 1, 1. So I plot the point 2, 1 right there. From there, I'm going to go up 5. 1, 2, 3, 4, 5, right 1. Or 1, 2, 3, 4, 5, left 1. And draw my steep, positive sloping line. Pretty simple. I think we just have 2 to go. I think I have 5 of these. Yeah, I have 5 of these all together. So let's go to our next one. Finally, I brought a plus in. This is going to be interesting. So let's just do it the same way we've been doing it. Underneath here, I'm going to write y minus y sub 1 equals negative 3 times x, or that should be an m. I'm doing the generic formula, times x minus x sub 1. Okay, so you can see the slope. Slope is negative 3. So I'm going to write that down. Now here's what's interesting about this one. So we know that in the regular formula for point slope, the minus right here is built in, and this up here is a minus, so that's like what we've been doing. Minus to minus means that your x sub 1 just sits behind that minus, so it's 1. So this is 1. But what's interesting here is that there's supposed to be a minus in front of the y sub 1, but this has a plus. So we are going to have to change that. We're going to have to force this to become a minus. That's the only way we can identify what y sub 1 really is. So how can we change a plus to a minus? Well, hopefully you're thinking that we could write it like this. Y minus negative 2. Double negative, right, will change right back to plus. So we've just changed the way it looks, not the value. And now we have the minus to the minus, and the y sub 1 sits behind that minus. So my y sub 1 is negative 2. That's the first one that had us do that. So really, when there's a plus instead of a minus, it changes that sign on the y sub 1. And then everything else flows the same. 1, negative 2, that would be here. 1, negative 2 would be there. And then my slope is negative 3. So from that point, I'll come down 3, right 1. Or I could go up 3, left 1 a couple times. Now, I think it's a good time to stop here and just talk to you about something kind of cool. I haven't brought it up yet, but I think now that you're getting the hang of this, now might be a good time to talk about it. I just want you to see something pretty cool. I wrote all over this, so I'm just going to bring the original equation down here. So the original point slope was y plus 2 equals negative 3 times the quantity x minus 1. And we totally rocked that out. We were able to plot this graph from point slope by identifying the slope and a point, and voila, we have it. But what if we manipulated point slope a little bit? In other words, when I see this negative 3 out in front of this quantity, I immediately start thinking about the distributive property, right? Let's go ahead and distribute. That would give me y plus 2 equals negative 3x plus 3 because of the negative times the negative. Now, if I solve this equation for y, in other words, get y alone, I would minus 2 from both sides. And that would give me y equals negative 3x plus 1, because 3 minus 2 is 1. Notice I went from point slope to slope intercept. Y equals mx plus b. Now check this out. If I were to graph this line, my b is positive 1, so I would go up 1 on the y-axis. Oh, look, I'm right there. I was already there. And from there, I would rock my slope down 3, right 1, 1, 2, 3 over 1, 1, 2, 3 over 1. Do you see how it's the same line? But I just manipulated point slope into slope intercept form. They're all connected. They're all the same line with the same points with the same slope. And if I wanted to, heck, I could go to standard form too. If I add my 3x over, I would have 3x plus y equals 1. If I wanted to graph this by using my intercepts, remember the good old intercepts? Say I have standard form. What's the use of standard form? Well, you can graph by the intercepts. If I want the y-intercept, I let the x be 0. You guys, if I let the x be 0, this is gone, and y is 1. Look where I am on the y-axis. Am I at 0, 1? Darn right I am. Now, if I want the x-intercept, I let y be 0. Well, if this is 0, this goes away, and I have 3x equals 1. If I divide both sides by 3, I get 1/3. Now that's not the prettiest, but look, where am I crossing the x-axis here? Look, right here. Doesn't that look about 1/3 of the way from 0 to 1? If you split 0 to 1 into 3 equal parts, that's about 1/3. They're all connected. Point slope, boom. To slope intercept, bam. To standard, ta-da. They're all just the same line in different outfits. So I hope you're catching that as we work through this. Okay, and my last example for this video would be example 5. This has back to point slope again. It's got the double plus, so we gotta be careful there. So let's think about this. Well, the slope's pretty easy to see, 3 over 2, right? And I guess the shortcut to identifying the point is to take the opposite of positive 2, which would be negative 2, and the opposite of positive 4, which would be negative 4. But the real reason is this. This would be written as y minus negative 4 equals 3 over 2 times x minus negative 2. So by rewriting minus negative 4 minus negative 2, now you can really see x sub 1, y sub 1. Okay? So we plot the point, negative 2, negative 4, negative 2, negative 4, which puts me here. My slope is up 3, right 2, up 3, right 2. And so here is my line. And I could check it. I could turn it into different outfits if I want to. For example, let me bring down the point slope. Y plus 4 equals 3 over 2, parentheses, x plus 2. Let me go ahead and distribute. That would give me y plus 4 equals 3 over 2x plus 3 over 2 times 2. Well, the 2's knock out. So it would just be 3. If I solve for y and subtract 4 from both sides, y will equal 3 over 2x minus 1. There is your slope-intercept form. Check it. Down 1, check. Up 3, right 2, check. So this launches me off of the y-intercept, negative 1, where when I graphed it up here, I launched from the point -2, -4, which still took me to that y-intercept. Now, if I want to rock standard form, sure can. I would have to move this x clear on over to the front here. I'd have to subtract it off of both sides. That would give me -3/2x plus y equals -1. Got to check in, whole, integer, integer. This is definitely not whole. It's a fraction and it's negative. So to compensate, I have to multiply by a negative to turn this positive, and then the 2 so that they knock out. So let me multiply everything by -2. Now if I distribute -2 through, a negative times a negative is a positive, and the 2's knock out, so really it's positive 3x. -2 times y is -2y. And finally, -2 times -1, +2. So there's my standard form. How do I graph from standard form? I make a chart. I find my intercepts. The y-intercept would let the x be 0. If I let the x be 0, bye-bye. I have -2y equals 2. Divide by -2, both sides, -1. Ta-da! 0, -1. Already got it. And if I let the y be 0, now this is gone. And I have 3x equals 2. Divide both sides by 3, and I've got 2/3. So I've got to check if my x-intercept is around 2/3 0. Let's see. Look where you're crossing the x-axis. Does it look about 2/3 of the way to 1? I think it's reasonable. It's a little hard to tell exactly because it is a fraction, but it's pretty reasonable on my graph. So I know I went off on a bit of a tangent here. We really just had to stop right here with point slope and draw the line, but I just want to connect the dots from point slope to slope intercept to standard. It's really cool how they all mix. Okay, that's it for this lesson, graphing. Our final video, which will come next, is actually writing equations of lines and point slope. So tune in for that if you need to. Thanks for watching.